So at point F, we were at the equivalence point. G, we surpassed the equivalence point by just a little bit, and now we're going to shoot on past that equivalence point in H. How do we work the problem? We start it the same way as we did for every other one except for A, and that is the reaction is taking place, going to completion, one-way arrow, plug in moles. So we have our moles here for the acid. To get the moles of the hydroxide, we look at the information that they gave me on the sodium hydroxide. So we take the molarity times the volume of that sodium hydroxide. So 0.249 moles per liter times the number of liters, in this case it's 25 milliliters or 0.025 liters. And that's going to give me the moles of sodium hydroxide, which is 0.06225. Okay, so now we can plug that value into my table, 0.6, I think I'm missing a 0. I am. 0.06225. Consume the smaller, which in this case it is once again the acid. Use the coefficients to tell you how to finish this change line. 0.0498 is being consumed of this one. Adding 0.00498 of that one. All of my weak acid has gone away. I still have some strong base present in here. It is 0.001245, and I have produced some of this weak base. Whoops, that's a 9. All right, 9.8. So now we have the values of our ICF table. We examine the F line. No weak acid, we have a strong base, and we have a weak base. The strong base wins. He declares a victory over the OH minus concentration. You don't even have to worry about that weak base at all. It doesn't contribute enough ions. So we take the moles of the strong base and we divide by the total volume. I remember to do it in my calculations this time. I had 20 milliliters of the acid, which is that many liters. I had 25 milliliters of the base, 25000, okay? So that's the milliliters of the acid converted to liters, milliliters of the base converted to liters, and that will give me the hydroxide concentration, which in this case, I don't know what it is. Well, dang it, I didn't put a number for that. Oh, yes, I did. It's 0.0277 is its concentration. That's the concentration of the base because we can base the problem on that value right there. Now, we can get the pOH from that number by taking the negative log of it. It is negative log of 0.0277. That's going to give me a pH of 1.558. Be careful. Realize that this is a pH that you just obtained, not a pOH that you obtained. So to get the pH, we have to take 14 minus that number. Okay, and that is going to give me 12.442. It has really risen a lot. Okay, so that is how you work it when you've got excess base, when you've got this sort of titration. There is no Kas to use. It's the simplest of them, but you just have to remember, use a strong base and ignore the weak base.